Our objective today is to apply segment and angle addition postulates. We're going to do that on the notes, but let's do this warm-up first. Everyone wrote it down in the journal with the objective, the I can statement, with the date. Now, we know together these two angles make this angle right here, which is 90, okay? So if this is 90 degrees, and we have two parts, who can tell me an equation I can set up? Addition? Okay, so I'm going to add this and this. Well, let's see. So I'm going to add these up. X plus 20, and I'm going to use parentheses. So the first angle is x plus 20 plus the other angle, which is 40. Now, what is that supposed to equal? We just said it adds up to 90, okay? Now, next step, if I see I have like terms, constants that can be combined, I should combine like terms. So 20 plus 40 gives me 60. So I bring down that x plus 60 equals 90, and my last step is I like to get rid of the loner, the 60, by doing the opposite. So minus 60, minus 60. So x equals 90 minus 60, 30. Now, if you got that right off the bat, cool. If you didn't, it's all right, because we're going to do some notes on angle addition postulate and segment addition postulate. So pass these out, and we're going to fill in the notes. Again, make sure you have this. That way on Friday, you don't have a blank or, you don't want to miss any points. Cool? These two are for y'all in the back. Got a pencil now? That's good. Okay, so you should be looking at this sheet right here. Okay, so notes, angles, and segment addition postulate, right? So, it says the segment addition postulate states that if we are given 2 points on a line segment, A and C. So let's draw a little diagram over here. Got point A, point C. Got my segment. It says a third point B lies on the line segment. So it doesn't have to be exactly in the middle, just somewhere between. If and only if the distance between the points meets the requirement of the equation AB plus BC equals AC. That's a lot of math lingo, okay? So it's telling you AB, this part, plus BC, this part, equals AC, which is all the way across. So I like to put this simply. So see these blanks we're going to fill in? To put it as simply as I can put it, part plus part equals the whole thing, right? AB is just the left part. BC is the right part. And then AC is all the way across, the whole thing. So whenever we're doing these addition postulates, this is basically, yes, you can write this down. Part plus the other part equals the whole thing. That's how you're going to set up these equations today, okay? If you know one part, you know the other part, add them up. Equal sign, whatever the whole thing is, okay? And it's going to be the same thing for angles. So on angles, the angle addition postulate states that if we are given an angle ABC, let's go ahead and draw that. So I got angle A, B, C. All right, and it says with a given point D between the rays of BA, rays. Sorry. So I'm going to put the letter D somewhere in here. It doesn't have to be exactly in the middle. And again, forgive my drawing, and I don't have rulers for y'all yet. So, okay. So you can kind of see that I've got two angles that are right next to each other. Okay. And it says we have adjacent angles ABD right here, and then angle DBC right here. If and only if angle ABD, this little one right here, yeah, this is a C. Okay, so ABD, this little angle, plus DBC, this bigger angle, equals ABC, which is the big outer angle. So once again, this is small part plus the other small part equals the big whole thing. Okay? So again, simply, part plus part equals whole. Whether it's segments, whether it's angles, whether it's anything in the world, your parts have to add up to the whole. That's just the way things are. Okay? Now, we're going to use that doing 1 and 2. Now, if you look at number 1, it's just a big blank space. That means that if they give us some information, we should probably draw it ourselves, which we're going to do. So number 1, given that R is between Fy. So let's go ahead and start drawing this. Fy, and put R somewhere in the middle. Doesn't have to be exactly in the middle. But I have a segment with the point FRY, right? Now, it tells us some values. FR is 3x minus 2. So I want to label that. FR, 3x minus 2. That's my first part. RY, 4x plus 7, is my other part. Cool? And then it tells me Fy, which is all the way across. I like to use a bracket to kind of show it's the whole thing, is 96. Now the warm-up was angles. This one's segments. Same idea. Okay? So this first part plus this second part equals this whole thing. Let's write it as an equation. So my first part is FR, for real, 3x minus 2. First part. Plus my other part, RY, 4x plus 7, equals, and what's the whole thing? 96. See how that works? Now, if you don't use parentheses, that's fine. I do like to use parentheses to kind of group things together. So, got that formula written? Now, we've been doing these on the warm-up, so you should know how to solve an equation. Now, I know it's kind of weird to have a bunch of stuff on the left side of the equation. Do y'all remember what we do when we have more than one thing on one side? Combine like terms, right? And in fact, there's 2 x's. There's also 2 constants. So we can combine 2 different things in one step, okay? So 3x plus 4x together, that gives me what? 7x. Now, don't forget the negative sign here. This is a negative 2 plus a 7. Okay, so negative 2 plus 7, if you're not sure, calculator can help you out, but it's 5, so put plus 5, equals, bring down 96. Now, we definitely did a lot of 2-step problems last week. What do I always get rid of first in a 2-step problem? The loner. The loner is what? The plus 5, right? Opposite of plus 5? Minus 5, minus 5. 7x equals 96 minus 5 is 91. And then to get rid of that 7, what do I do? Divide by 7, divide by 7. So x equals 13. If you didn't know 91 divided by 7 is 13, calculator's your friend. Now real quick, we did what we were supposed to. We solved for x. But sometimes you might be asked to find a value. So if they said, you know, what's FR equal to? Could you plug 13 back into x? So 3 times 13 minus 2. Okay? You could get a value if they asked you for it. They didn't, but I'm just saying, it's possible, right? Look at number 2. Now, on number 2, do we know the first part? Do we know the second part? Do we have labeled down here the whole thing? No. But that's why we got to read our question. The question says, solve for x given QS. QS is the whole thing, right? QS is what? 15x plus 2. Do you see how that works? You know the first part, you know the second part, and the question itself told us the whole thing. Now, I'm telling you, a lot of people get tricked up on this problem, okay? So everyone answer this with me. Look right here. Look, look, look. Don't get ahead of me. What's the first part? 5x minus 2, right? What's the second part? Which one of these? 10. Okay? A lot of people are adding these two together. It's part plus part equals whole. Okay? So it's not going to look exactly like the last equation. It will, yeah. But I'm saying when you set it up, you just write it the way it was, and then you go from there, yeah. Okay, so I'm going to give you a couple minutes, maybe 3. I want you to try to set this up and solve it. If I can get this to work. Boom. All right, go ahead and try to solve that one. All right. See what y'all got. Dang. You know how to do it? You can ask questions. Because I want to help you out. You got to know it. Number 2, again, The whole thing we've been learning is part plus part equals whole. So the first part, 5x minus 2, right? Okay, plus, now the other part is actually 10, right? So you have to put 5x minus 2 plus 10 equals, and then the whole thing is down here, 15x plus 2. Okay? If you had these switched, it's not going to give you the right answer, okay? So, now on the left side, what can I combine here? Okay, negative 2 and 10 gives us what? Positive 8. So bring down 5x plus 8 equals 15x plus 2. Okay, x is on both sides. Can it be on both sides? Not on both sides. So we got to get rid of one. Let's get rid of the smaller one, which is 5x. How do I get rid of a positive 5x? Subtract. So minus 5x, minus 5x. Okay, bring down 8 equals 15 minus 5, 10x plus 2. Now, x is on the right-hand side, so we're going to solve for x over there. What do we get rid of first? The loner is positive 2. What do I do? Minus 2, minus 2. 8 minus 2 is 6, and that equals 10x. To get rid of 10, what are we going to do? Divide. Now, if you type in your calculator 6 over 10, it'll probably tell you x equals 3 over 5. It'll reduce the fraction for you. If you hit Control Enter, it'll probably tell you 0.6. But basically the answer is not a whole number. It's a decimal or a fraction, okay? So, again, part plus part equals the whole thing for segments and for angles, okay? So, and you can rewrite that right there, same thing, part plus. Okay. Well, I'm just telling you it's the same thing as the top. So, we can come back to it. Okay. All right, so on the back, flip it over, please. Now, this is actually a throwback to when we did angle vocab last week, I think. Let's see if y'all know what these are called. What do you call these two angles that are across from each other? So they're actually not adjacent. Adjacent is next to each other. So like this and this, those are adjacent, okay? Next to each other. But across from each other, this and this, what do y'all think? So today, everyone needs to know this word. Vertical angles, okay? Now usually vertical means up and down, right? But for angles, it doesn't mean up and down. It just means they're across from each other. So even if it's like number 4, see how they're across from each other? They're not vertical, they're sideways. But still, you call them vertical angles. You see 2 little V's. So, now what do we know about vertical angles from our notes from last week? They are what? Okay, they're congruent. The values are equal. So put those arcs there. That shows me that you know that this is the same as this. Okay? Do that now. Make those little arcs, okay? And if we know they're congruent, we know the values are equal, right? What do I do with equal things? What do I put between equal things? Not addition. What do I put between equal things? An equal sign. Okay? So that's what I'm going to do. I'm going to take 6x minus 12 and then equals 3x plus 18. I want everyone to hear me say this. This is not angle addition because it's not part plus part equals whole. This is just you got to know opposite angles are equal. Put an equal sign. Okay? Now, x is on both sides. What do I do again? Subtract the smaller one, or get rid of the smaller one. Since it is positive, we are going to subtract 3x from both sides. 6x minus 3x is 3x. Bring down minus 12, equal sign, 18. Bring that down. Two-step problem. What did we get rid of first? The loner. The loner is minus 12, so we're going to add 12. What's 18 plus 12? Bring down 3x, equal sign, and you said 30? Okay, 18 plus 12 gave us 30, and then last step to get rid of that 3. Divide by 3. Okay, what is 30 divided by 3? 10. So we said these are vertical angles right here. And then x equals, we just put 10. That's it. So everyone knows angles across at an intersection are equal. Okay? So I want you to try number 4. It's basically the same type of problem. So let's see you do it. All right, here we go. So again, these are called what angles? Vertical. So they're across, so they're equal in their measurement. They're congruent angles. Vertical angles. So you set this up. You did 9x minus 10 equals 8x minus 2. You got rid of the smaller x, minus 8x on both sides. 9x minus 8x, if you put 1x, that's okay. But 1x is just x, right? Bring down minus 10 equals negative 2. And you got rid of your loner by adding 10. So did you get 8? If you got 1x equals 8, again, that's the same thing as x equals 8. Cool? And if I asked you to, you could plug it back in and give me these angles. 9 times 8 minus 10, right? Hopefully. Okay, now back to angle addition postulate. We're thinking about part plus part equals whole, right? So for number 5, we got 3x, it says angle, the measure of angle PLV. Now if you watch P to L to V, okay, that's this angle right here. Let's label that 3x plus 2. And the next one says the measure of angle VLM. So I'm going to use 2 arcs to show that it's different, and that's x minus 5. Okay? And then it says PLM. Now that's the whole thing, right? So I'm going to use, whoops. The whole big angle is 125. So I got a part, I got a part, I got a whole. Like we said on the front side of this, part plus part equals whole, right? So let's set up this equation. The first angle is 3x plus 2 plus x minus 5 equals 125. Now, on the left-hand side, we got multiple x's and multiple constants. Let's combine those like terms. So 3x plus 1x, 4x, 2 minus 5, negative 3. So we'll put minus 3, equal sign, 125. And then, two-step problem. Get rid of what first? Loner is minus 3, so let's add 3. 4x equals 128. And then to get rid of that 4, we divide. What's 128 divided by 4? 32. Okay? So up here, put 32. Now, we need to write the angle pair. What? Okay, so first of all, do those angles add up to 90? No. So they're not complementary. Do they add up to 180? No, they're not supplementary. They're not a linear pair. It looks like those two angles are just next to each other. So what do you call angles that are just next to each other? Adjacent. If you haven't been here, you need to know that word. Adjacent. So let's write it down. Adjacent. Has a J in there. Adjacent just means two angles next to each other. That's it. Okay. All right. I want you to do number 6, and then I'll see what you got in a couple minutes, okay? So everyone's going to try number 6 on their own. All right, let's talk about this. So, does everyone see that we have these two angles, right? Again, they're next to each other. What does that mean they're called? They're adjacent. Now, it's true they're adjacent, but they might have a more specific name. Now, again, they're next to each other, and they make a what? Straight line, right? Which is, I know the whole, like we have a part and a part, but we don't have the whole thing labeled, but we know the whole thing is how many degrees. Straight line is always 180, right? So, again, they don't always label stuff, but you can know it if you know a few things, right? So again, straight line's 180. You should have set it up like this. 2x plus 4 plus 2x equals 180. And so that'll be our next step. So we're going to combine like terms. 2x plus 2x is 4x. Bring down plus 4 equals 180. Get rid of the loner, so minus 4. 4x equals 176. And then we're going to divide by the coefficient 4. And we get x equals what? So up here, x is 44. Now real quick, whether you were here or not, you need to know this vocab. What do you call two angles that are adjacent that make a straight line? Okay, so complementary adds up to 90, so not complementary. Supplementary. Now, you can call it supplementary, but there's another name. If they are adjacent, you can call them a linear pair. Okay? So specifically, I would call this a linear pair. Just in time. Linear pair slash, you could put supplementary, that's fine. Okay? Keep this. We're going to do an assignment tomorrow using these notes. Okay?